All right, hi folks. Just checking in to wrap up the end of what we're doing here with our systems, and we are going to be looking at just as inverses and using those to solve systems one more time. So let's just quick hash through what we talked about the other day. So remember, we talked about the identity matrix, that reduced row echelon form that we saw from before. And these identity matrix are called the identity matrix because whenever you multiply a matrix by the identity matrix, you get that same matrix, no matter the order. Now, throughout the process, I did a lot of comparing that to just multiplying numbers. If I multiply 3 times 1/3, 3 and 1/3 are multiplicative inverses. When I multiply them, they cancel each other out. So A inverse times A is going to get the identity. 3 times 1/3, those are multiplicative inverses. When I multiply them, I get the multiplicative identity, which is 1. If I multiply any number by 1, I get that number. 1's the multiplicative identity. Well, now we're talking about matrices. A matrix times its inverse gives us the identity matrix, no matter the order that we do that. So I showed you how we come up with that identity matrix, not the identity, the inverse matrix. We start by placing an identity matrix to the right of our matrix. We get the matrix then into reduced row echelon form, and what we have left on the right side is our inverse. And on this one, we just double checked it. We multiplied the inverse times our original matrix, and we did end up with that identity matrix there right behind me. So we did this example where we took a system and we wrote it as a matrix equation. We put our coefficients in our first matrix, our variables in our second, and our constants in the third matrix on the other side of the equal sign. Now, why do we do that? Well, we talked about the other day how we multiply matrices. How do I take matrix A times matrix X? We take row by column. -2 times X plus 3 times Y equals 4. That's our first equation. -3 times X plus 4 times Y equals 5. That's our second equation. Because of the way that matrix multiplication is defined, we can easily take a system and write it as a matrix equation. So we have A times X equals B. And right here I worked us through that. And I said, okay, if A times X equals B and we want to solve it for X, we have to get rid of the A. Well, how do we cancel out a matrix? By multiplying by its inverse. So we multiplied by A inverse on the left. Well, if I multiply by A inverse on the left, I have to do the same thing on the other side of the equal sign. Now, remember that the order that we do multiply matrices is important. I put A inverse to the left, so this has to be on the left of B. A inverse times A, they cancel each other out, leaving us the identity. So we have the identity times X, and if I take any matrix and multiply by the identity, I get that same matrix. So you end up with X equals A inverse times B. So what we did here is we said, okay, if that's matrix A, that's matrix X, that's matrix B. To solve that, we're going to do A inverse times B. I didn't get that written down. I think you probably did in class the other day, but let me just review how to do this on our calculator. If I can find it. There it is. All right, so I'm going to go into matrix. I'm going to edit matrix A. That's a 2 by 2, -2, 3, -3, 4. I'm going to quit. I'm going to go into matrix. I'm going to edit a matrix B. That's this one over here. It's a 2 by 1. And that's going to be 4, 5. And I'll quit out of that. Now, I'll show you this. If I want, I can take matrix A inverse, that's the inverse button, notice the -1 there, This is A inverse. This is the inverse of that matrix A. Notice if I multiply those, 4 times negative 2 plus 3, 4 times negative 2 plus negative 3, I'm getting this all turned around, sorry. 4 times negative 2 plus negative 3 times negative 3, there it is, that gives us 1. If I go up here, 4 times 3 is 12, plus negative 3 times 4 is negative 12, that's 0. When I multiply these, I do get the identity matrix. But we don't even need to worry about finding that because our calculator will do that for us. So I'm going to go matrix A inverse, right here, times matrix B. And I get the matrix 1, oops, 2. Now remember this big X, that's a capital X for the name of that matrix. This is a little x, there's Y. So what is X? 1. What is Y? 2. The solution to this is 1, 2. All right. Have we done a four variable, 4 equation problem yet? I don't know if we have, so let's do one. Okay. Here's our system. 4 variables, 4 equations. Let's just double check that the order is good. I've got W's there, X's, Y's, and Z's equals constants. This is good. Let's put this into a matrix equation. There's our coefficient matrix. We multiply that by our variable matrix. And that equals our constants. Okay. Let's double check that that works. Does 5 times W plus negative 4 times X plus 3 times Y plus negative 2 times Z equal negative 6? Yeah, that's our first equation. We're multiplying row by column. It all works out. Now if we call this matrix A, that's our variable matrix X, and that's B. We know A times X equals B, so how do we solve that again? We end up with X equals A inverse times B. It's nice when you write this matrix equation, we don't have to do all this work every time because we just know it works. We've done it once already. So I can go right to my calculator here. Let's edit matrix A into a 4 by 4. There it is. Now I'm going to go in to edit my matrix B. Instead of 2 by 1, I'm going to make that a 4 by 1. I can quit out. I'll go matrix A inverse times matrix B. There it is. Oh man, I'm glad I wasn't solving this one by hand. We ended up with some not very pleasant values. Okay, we'll just round here. Say about negative 1.1, 0.5, negative 1.4, negative 2.9. So now we have every variable. W is about negative 1.1. That was our top. X is about 0.5. Y is about negative 1.4. And Z is about negative 2.9. Alright, so as long as you have a system in the correct order, write your coefficient matrix, your constant matrix, call it A, call it B. X equals A inverse times B. Using the technology that we have, we can solve these systems very quickly. So with that, I'll turn it over to you guys. Thanks for tuning in.